Okay.
Alrighty.
Well, welcome to the July 20th, 2021 session of TangerineSDR and Hamside technical session. My name is Dave, KV0S, and this week I did a few things. I cleaned up my computer station and built a little extra shelving. And then I've been working on the Tangerine programmer version as far as I can work from my end, and have made some progress and continue to be working on that. So that's it for me. I think that's it. Next on the list, we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks a lot, Dave. Things are going well here. Let's see, some news. UHA released an update for his chirp sounder code. So there was a memory leak in it, which would cause it to stop collecting data after some time. But we think we have that fixed now, and he fixed some other additional scheduling error. So it should be collecting more ionograms than before. And the other big news is this week is Radio Blaster physics camp here at the University of Scranton. It starts tomorrow. It's 3 days long, and Scotty is here to help us with it. So W2NF, back to net.
Well, fine business. And next on the list is Dev, KC3PBE. Go ahead, Dev.
Hello, good evening, everyone. So I think we are starting in a good spirit, as Nathaniel said. So I also think that I have finalized debugging the course to generate stack plots of the qgrams which shows the variabilities in the ionosphere as detected by the chop sounder system we have installed here at the Scranton. Here in Scranton. So I think we're in high spirit this Monday. Thank you.
Very good. Next on the list is Jim, K4BSE. Go ahead, Jim.
Good evening, all. I am trying to get my head back out of the sand now. I was on vacation in Florida, lying on the beach and at a family reunion last week, and trying to get back into it now. And I was doing something else while Nathaniel was giving his report. But Nathaniel, were you talking about a memory leak in the Grape 1 software? Because I hit that when I was out of town and I can't get it to take any more data now.
No, that was this is a memory leak in a completely different software set. I haven't seen a memory leak in the Grape 1 software yet, so that's news to me. Back to you.
I copied to another computer and deleted all of the files on the all the files that were made on the Grape, and still there is no room on that memory card for any more data. And I know you said you had not had that problem using, I guess, the same release software. It's as far as I know, the current release of software, but something is causing me trouble. I have not had a chance to spend much time on it to try to get to the bottom of it.
Yeah, we'd be really interested to know what's wrong with that, because that is definitely not an experience I've had. So it'd be good to find out why you're having that. Back to you.
Yeah, I wonder if anybody else has noticed that, or am I the Lone Ranger out in left field?
Yeah, no, I don't know if anyone else has either.
I had a similar problem with the FL-Digi filling up the memory on my my regular digital setup, and I had to go in and delete all of the WAV files.
Are you saving WAV files? Is that what's happening?
Yeah, I am, and that I turned that off. You can turn it off, and also there's a selection on the menu where you go in and delete all of the audio files.
That might is that your problem too, Jim?
Let me look. I haven't seen any WAV files. I've just seen the data files and the graphs. I will go in and look at that and see what I can find. That's good information. Thank you.
I'm not sure if it's actually a .wav, but it's a .something audio file.
Yeah, I didn't know those were being saved. I will check on that. And FLDigi is doing that?
I cleared up my problem right away and cleared up something like 11 gigabytes of memory on the 32 gig card for my regular FT8 and everything else digital communication setup.
That's very interesting. I will go in and look for that because that may well be my problem. Do you remember where those audio files were being saved on the card?
I don't, but I can go in and find it, and I'll send you an email. But they're up at in the menu structure of FLDigi, there's a selection there for saving or not saving different types of files, and also for deleting files. So go look in your menu structure on FLDigi and see if you can find that. Meanwhile, I'll look as soon as we're done here and send you an email, Jim.
I appreciate it.
I just put in the chat a link to a list of various different disk analyzer packages. You run one of these disk analyzer packages and it will tell you where your overloaded directory is. It'll show it, most of them show it graphically, and it'll take you right to it.
Okay, great. Thank you. I will check that too, and I'll figure it out. Thank you.
And Jim, you know much more about this than I do, and so I'm sure you've done this, but this may be worth adding for new users like myself. When I first, I followed all the directions for setting up the Grape, and I realized I didn't have much hard or drive space, and I had to go into the configuration of Raspberry Pi and make it accept the whole contents of the SD card or micro SD card. So I'm sure you've done that, but that would be something to add to just the general instructions for new users. Because I mean, this is the first time I ever had a Grape, and I set it up, and I had some issues, and I had a friend who knew Linux a little bit more, and he's like, oh, well, it says you have very little space left. And then he figured out how to do that. It was a problem I didn't identify that he did and was able to solve. But so that's something to add to the documentation. It's probably not your issue, but.
Yeah, I appreciate that very much, David. I'm 99% sure that's not my issue. I remember doing that, but that is a good point to add that to the instructions.
Well, are you done, Jim?
Yes, I am. Thank you.
Well, next on the list, we have Tom McDermott in 5EG. You moved yourself up to the top of the list. Go ahead, Tom.
Good heavens, it's hard to be at the top of the list. Let's see. First thing, I ordered one of the Intel FPGA development boards from Mauser. Got a quoted date of July 14th. The 14th arrived and the delivery date slipped. And on Friday, the delivery date is now showing December 7th. So it appears that not only are the FPGAs unobtainium, but the development boards are as well. So pretty disastrous there. Continuing work on the WX Python tool, GUI tool for checking and manipulating the module and ASIC registers on all the cards, and been going through Python and exception handling for attributes and trying to close sockets and stuff like that. That's it. Back to the group.
Two things I wanted to mention. One is George McFadden offered the use of his dev board. So he has one. And the other one was Tom, I don't know, is it like the July 10th, recorded a GNU radio session. I haven't seen the video on YouTube yet, but You did do that, right?
I haven't recorded anything.
Oh, I thought you had a talk for the GNU
I'm
amateur
sorry.
radio GNU users.
Yeah, I'm sorry. That, I don't know who recorded that. That was the amateur radio meetup. I gave a presentation on characterizing SDR receivers using GNU radio to do all of the measurements, dynamic range, noise figure, all of those kind of things using GNU radio. Hopefully that's recorded. I don't know where the link is. I haven't gone back to the chat.
I've looked for it and haven't found it yet, but they said they would post it this week.
Okay.
John Ackerman has one from June, which was quite good, where he
Okay.
talked about GPSs as well. So next on the list, we have Bill, AB4EJ. Welcome back, Bill.
Thanks very much, Dave. Good evening to you. Good evening to the net. Been pretty busy here the past few days. We had 4 grandchildren, ages 11, 9, 6, and 4 here for a number of days, and it was wild and crazy time was had by all. Got all except the 4-year-old up on skis. So that was a good week. So anyway, recovering from that, but I've been doing some code cleanup on the calibration routine, so it is able to coexist with the magnetometer running. I mean, obviously, when you're going to run calibration, the system takes over the run mag subroutine, and then you got to restart it again when you're done. But anyway, what this does is it allows you to go out in your yard and look at the local host, and it shows you the XYZ readings, and you can rotate your magnetometer while looking at the continuous output until you get the Z-axis zeroed out, or as close to 0 as possible. I haven't been able to get it exactly to 0, but if the numbers are usually in the tens of thousands or 20,000 or 40,000 something, if you can get it down into below 100, that's plus or minus 100 from 0. You're pretty close to aligned with the magnetic field of the Earth. Also been putting in some more unit tests into the local host software, also working on the observations table in the central control system, designing that so that database will be there and our students can jump right on it when they come back in about 3 weeks. And looking at maybe giving a talk at DCC about the testing I have done in the magnetometer with exposing the magnetometer to various levels of RF, and also the techniques I've used for eliminating noise that were apparently coming out of the magnetometer. Turned out the magnetometer line that goes out to the yard is able to radiate noise from a switching power supply. Anyway, thinking about maybe giving a talk at DCC just to give engineering tips on the use of the magnetometer. So anyway, that's the...
Well, fine business, Bill. And next on the list is Bill N8ET. Go ahead, Bill.
Gave me a little more time to get ready to warm up this week. Took me off the top of the list and pulled me down towards the bottom. I haven't done much this week. I've had a couple tests down in Columbus. Had a bone scan and a CAT scan and a chest x-ray and all kinds of things, and filled me up with all radioactive dye. And so I lit up for a couple days. I think I must have cooled down by now, and so far everything's come back clean. But that was a big thing this week. Today I was out screwing in guy anchors on the tower that looked like it was about ready to fall over, and I got the separate beam pointed back at the horizon instead of at the moon, so that's better now. I can sleep at night. But I think this next week I'll get back to the grape and see if I can solder some of the stuff with one end on the surface mount board and get that thing running. So that's about it for this week. We'll see you next week.
Sounds like a busy week. Next on the list, we have Kong. Go ahead, Kong.
Hello, everyone. So this week I continue working on the digital filters in the data engine. specifically on the mechanism to detect overflow in the filter. And I also attempted to write the timing constraint file for that digital filter, and also try to learn more about the signal type analyzer. So that's it for me. Back to you, Dave.
Well, sounds like a busy week.
It could have been more busy than I expected. Oh, and also I will be helping with the physics, the radio blaster camp tomorrow with the
Yes,
That's gonna be exciting.
enjoy.
Thank you.
Next on the list, we have Dan in for XWE. Go ahead, Dan.
Oh, thank you, Dave, and good evening, everyone. Well, I mentioned at the beginning, I think before everybody was here, a little bit about my adventures with weather balloons this last week, and along with that, I bought an RTL SDR to use as a receiver. And I had one years ago. I actually gave it away. I think I gave it to you, Dave.
Yeah, I think you did.
And the reason I gave it away was because it had such bad frequency stability. And I guess now the better quality ones have TCXOs in them.
Yes.
So they're a little more stable. Anyway, I'm kind of playing with that, and that's about it from here.
Well, fine business. And next on the list, we have Dave, KD0EAG. Go ahead, Dave.
Hello. I've been staying busy doing something. I guess I've been working on a local net monitoring app that lets you watch the magnetometer data, plots it, and displays it, and hopefully will let you write configuration files and control it and stuff. This is for users who are not necessarily contemplating using it for the PSWS project, but people who are interested in either grabbing data now and watching it, or just interested in magnetometry as a standalone thing. So that's been occupying me lately. I can't remember anything else except that the lawnmower guy came this afternoon, and I'm kind of suspicious that he may have eaten up my Cat 6 cable out there, because things have all gone haywire. Anyway, that's it for me.
Well, fine business. And next on the list is David McGaw. Go ahead.
Good evening. First, let's see, a number of things. First, I'll mention, since it just came up, RTL SDR. We use these a lot and have a very good clock going into it. Yeah, they have TCXO now on the ones that are bought for SDR use, and fairly good. But I actually pull that guy out and put an external clock in there, coming from a synthesizer running off of GPSDO. Similar to what you would do with a Leo Bodnar. In fact, the first system that we did this with, we were using a Leo Bodnar reference. But I synthesized at 28.8 megahertz, pop that in there. If anyone's interested in how you do it, I'd be happy to send some pictures. Also, I'll point out, though, that UHA has been doing that to synchronize multiple SDRs for some time. Second, I've got my Max 10 up, and I'm working with it. And my big question is there a way to get RF into it that's relatively straightforward? What have people been doing? I've got a RedPataya, I've got some other SDRs. Are those able to get usable data in, or do you have other ways of doing that? And the other thing about ground and radiation and things like that, there's a commission that's been put together kind of informally maybe for down in Antarctica, keeping things quiet for us experimenters, which I seem to be on as a contributor to that. So we might collaborate on these ideas that of documenting, keeping RF and interference off of the cables and where it belongs. So back to Nat.
Well, fine business. And next on the list is David, KE8QEP. Go ahead, David.
Okay, hello everyone. I'm in actually visiting my folks here in New Jersey, and I tried setting up outside, but it was a little dark. But if the curtains weren't here, and I cut down the trees, you could actually see into Pennsylvania. Yeah, because I'm 7 miles from Washington Crossing, but there is a curtain and there are trees. So I've been playing around with some of the magnetometer data, and I managed to, I can't say programmed or coded, I managed to get some lines of stuff together that would look at the folder of all of the logs and summarize each line. So I have, a daily tally of standard deviation and range and things like that. And it was interesting. Actually, one of the really interesting things is that I don't seem to have a diurnal temperature fluctuation. It seems to be semi-weekly, in the 4 to 8 day range. I don't have enough data to make any conclusion there. I don't think that's relevant to the project, but anytime I see a pattern in some kind of data, it's somewhat interesting. And then I get easily distracted. But I think some of these summaries clearly show when things go a little wonky or cables have been cut or things have been unplugged. So it could be more elegantly coded, but I'll look at it more and try to do a little write-up. Write-up may be too formal, but I think it shows when things have gone cattywampus. So back to that.
Well, fine business. And one of the things I talked to David about was some ideas about finding issues with data that makes sense or doesn't make sense. And so we've had some offline discussions about that, or side discussions, I guess I should say. So next on the list is, we did Josh. So James, KG4DSG. Go ahead, James.
Oh, good evening, Dave. Good evening to the group. Let me start by apologizing. I know at the end of the last meeting, we were scampering around looking for dev kits, and I'm the one that mentioned that Mouser was supposed to have them. I noticed as the week went on that their expected arrival date disappeared. Tom said that he tried to order and has gotten a pushback. But the units that may have gone to Mouser apparently are now at Dikikey. They're showing in stock 24 units, if anybody's still looking for those. I don't know if I can believe that either, but that just appeared this week also. In addition, apparently Raspberry Pi 4s have hit the national or the international chip shortage, and they're unobtainium. I've even gone back to Newark and Element 14 as the major distributor, and they are all back ordered. So not a good day, not a good week. And I have no idea how long that's going to last. With that, back to the net.
Well, fine business. And next on the list is Jay, WB8SBI. Go ahead, Jay.
Well, good evening out there to all the fraternal brothers and sisters in amateur radio. Not a whole heck of a lot here. Been very busy with Society of Automotive Engineers cybersecurity issues, and just got a big new assignment from them to write a whole chapter on one of the upcoming standards. So that's been soaking up a lot of my time. And there have been some other personal things here, so haven't really had a chance to play, to be involved in this project, but I'm hoping to be able to clear some time and get back into things. Other than that, not much is new here. Take care, everybody. Stay safe, and get your shots if you haven't already had them. Back to net control.
Fine business, and best of luck to you. And next on the list, let's see, Joe, W7LUX. Go ahead.
Yeah, good evening, Dave, and everyone on the group here. I discovered the problem with the FLDigi filling up the disk with audio files, and there is a separate directory for the actual data. In other words, the comma space variable data and the audio files. So you have to go in and turn that off, but by default it's turned on. And suddenly my my Raspberry Pi totally froze up, and I had to restart it. I couldn't get the thing to respond, and it absolutely totally froze with a disk full message. Anyway, if you go in and I just deleted all the audio files, that saved the day. I've been collecting 10 megahertz WWV information from the grape, and not sure what to do with it. It'd probably be nice to have some place to send all of those CSV files. Other than that, we finally got our summer rainy season, and that includes, of course, a fair amount of lightning. So there are times when I'm either on the air or have the antennas disconnected because, well, one lightning strike was close enough that it shook the house. So that gets a little unnerving. Anyway, pretty much what's happening here. Back to you, Dave.
Well, fine business. And next on the list, we have Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. There was a lot of progress being made this weekend. I was able to fully assemble and test my active VLF antenna. I got the copper tape and finished up the antenna foam insert. I had trouble because of how long it was and how much thickness that was added due to the copper tape. So what I did was I put the antenna element in the pipe, and I used a smaller length of foam to hold the board, the VLF receiver board in place. And I used Michael's suggestion of the button, and that worked perfectly. So I have a pull string on there. I could pull out the bottom foam insert, which is the board. I took it outside to test it, and it works really well. I was extremely happy. So I was able to use my test box to power it, both from battery and from a DC adapter. The DC adapter added a little bit of extra noise, but other than that, it's probably nothing that the software can't filter out. I was also able to connect the audio output directly to my phone, and I used an app to display the live spectrogram. I'm in a location where there's a lot of power line interference, a lot of hum. So that kind of overloaded the signal a little bit, but you could still hear spherics pretty clearly. When it comes to general discussion, I'd like to show some pictures of my progress and the spectrogram. Also, there was a Nathaniel and I were discussing about conduit, and I was doing a little bit of reading today, and I'm not really sure which conduit would be best for direct burial, whether that would be solid PVC or plastic flexible conduit. Obviously, it has to be strong enough where the weighted soil doesn't crush it and prevent running new cables inside it. And as long as solid PVC, solid PVC is chemically welded right, then there shouldn't be any leaks. And as long as the ends are kept away from moisture, there also shouldn't be any leaks. And I was wondering if anybody had any opinions on what is the best conduit to use, what's best flex conduit, what kind of flex conduit or solid PVC to use for underground, and what sort of bedding that also should be used, if anyone has any opinions on that. Other than that, back to the net.
Well, fine business. And next on the list, we have Jules, K2KGJ. Go ahead, Jules. You can see Jules' link. His mic is unmuted, but I'm not hearing anything. Now I can see something. Well, we'll come back to Jules and see if he's got anything. Next on,
can you hear me now?
now I can hear you. Yes,
Sorry
go
about
ahead.
that. Mic wasn't plugged in. Just good evening to the net. Nothing much to report here for this week and back to go.
Fine business. And next on the list, we have Con, KE8QWB. Go ahead, Con. Con also seems to have his mic unplugged. Are you there? Well, let's go on to Michael, AA8K. Go ahead, Michael.
Well, thank you. Greetings to everyone listening. Back to you, Dave.
Fine business. And next on the list is Scotty, WA2DFI. Are you in Pennsylvania?
I am. Can you hear me okay?
Yes.
Yep, I'm at the hotel here in the Railroad Hotel in Scranton. Very awesome place. So got a 6th floor view of downtown. So it took me a while to get the stupid computer to work, but once I figured out how to do that, I mean, computers are not my friend these days. But anyway, this week, Dave and everyone worked with our CAD guy and pretty much got all of the drawings synchronized and finalized and cleaned up and ready to go, assuming we never get any FPGAs. Also spent some time with the FPGA rep trying to figure out what would be the best one. And he's off working on now on pricing and availability of an ARIA 10 FPGA for phase 2. may opt to do it, to go that route. Let's see. Also, we did get approval from the Tapper board. I don't know if we talked about this last time, but the motion was passed to fund the magnetometer next revision, the production version. So, actually, the CAD guy is working on the preliminaries of that right now. So, as soon as I get something to show, I will have. I'll bring it up to the guys here, Jules and Dave, etc., and see what they think. See if we caught everything. We got everything all set to go, and then he can proceed to route it, and we can go from there. And by the way, the Tapper proposal includes a prototype run of 10 pieces, so we'll have 5 more sets to test the instructions on and make sure everything works, and for Dave to print up some new brackets if they need to be changed, whatever he needs to do to make sure that they will fit. And I think that's about it for this week. Looking forward to this week at Radio Blaster Camp. Got to be Blaster Camp, so it's going to be awesome. So back to you, Dave.
Fine business. And we talked to Tom already, so we have Ward Silver in 0AX. Go ahead, Ward.
Why, thank you. Unmuted here. I have not been attending regularly lately. Too many projects, too many books. And I got some nice boards for the magnetometer from Scotty. Ordered some parts. I have some parts. I have to get some more parts. And then I will try to get this all working. Had a couple of zombie projects that simply would not die. And so now I'm starting to get to that. And I worked 3 JAs on 6 meters today. So there you go. I actually do some ham radio now and then, as opposed to just writing to it about it. And that is all I have. Oh, that's not so. There were 2 lightning damaged RBN nodes with the red pitaya. NP2X took a shot, was not direct, but it was nearby, sufficiently nearby to cause problems. So we're getting him, RBN has some replacements and they're getting one, but point is that if you use a red pitaya, they don't know about lightning. And so you should get a lightning protector either from DX Engineering or some other place. They have the little 75 ohms things that are about that long. I realize this is not a precision measurement, about the size of your little finger. And they go in an F to F connector environment. They will help with differential signals that come down the line. They will not help if you're getting lightning surges on USB, which is notoriously fragile for that kind of thing. And you will need to do something else there. I recommend something about grounding and bonding for some reason. Try to mount everything on one metal panel or in a metal enclosure so that everything's at the same voltage and goes up and down together. Good luck with that. And then the other one was damaged in Fiji. And apparently the heat sink for the chip was not attached properly at the factory. And so there was a little bit of here I'm demonstrating a misalignment, not to scale, between the heatsink and the top of the chip. And that caused it to overheat and damage itself. So you might want to check that out. We have replacements for both. And I inquired today about getting an RBN node in Punta Arenas, Chile, which is almost in Patagonia, if not in Patagonia. And we really, really, really need a node down there at the tip of South America near Cape Horn. That would be a brand new region for us. So that's my report. Back to Ned.
Well, fine business. So I think that except for the people who had microphone problems, we've talked to everybody and we're just about ready for open discussion. Does anybody that didn't speak get a chance to get their microphone fixed? Well, we'll just open it for general discussion, and if you do get your microphone fixed, you can jump in and add your 2 cents. So
Hey, I wanted to tell Tom, I did manage to get hold of George's board.
Oh, excellent, excellent. That's good news.
Maybe moot now because they're available at Dikikey, but I got it anyway.
Okay, well, good.
I just placed an order for 2 boards at Dikikey, so we'll see if they show up too.
Okay, monitor for a week and see if the date suddenly changes.
Sounds good. As soon as they gave the information, I went on and ordered it. And this is the magnetometer set that Majid made for me. So we still have to get it in the ground, but I have it here. So it has the he 3D printed this very nice little sleeve that holds the magnetometer inside the pipe. Like that.
And that's an 1.5-inch pipe, right?
I
Not a
believe
2-inch
so.
one?
I think it's 1.5 inches. Yeah. And
looks
then
like
he soldered the wires directly to the bottom of the board. So we're not using the Ethernet or RJ45 connector there, since it's not actually Ethernet.
Oh,
And then when we put the RJ45 connectors on there, we should use shielded connectors. Is that right?
correct.
Correct.
Okay.
Yes.
Okay.
And
what you might
the
want
other,
to consider, Nathaniel, is not putting that down at the very bottom of the pipe. Keep it up a couple inches. That gives you some tolerance of some water intrusion before it fries the board.
Okay.
yeah, although, I have not had problem with water with either of my sets for over 2 years now, or a year and a half at any rate. And if you seal it well with RTV, you'll be fine.
Okay.
What was that about shielded connectors?
Pardon me?
What was that about shielded connectors? Where?
The bulkhead connector is a female to female shielded.
Oh, okay.
So it carries the shield all the way through to the board. And I noticed that he also used a strain relief on that after they soldered the wires. There's a tie wrap as a strain relief at the bottom of the board, which is good.
Yeah.
Oh, down at the other.
We're going to have to.
As long as the shields are well away from the magnetometer, because
yep,
shielded Ethernet connectors are magnetic.
So Jules, if
well,
you
not
seal,
these. These are these particular ones are.
These are non-magnetic.
Yeah, correct.
So we have to. So we need to get the shielded Ethernet connectors that you recommend then.
Correct.
Right.
Okay.
Yeah, if you could document that.
Okay.
so if you seal the pipe with RTV, can you get it apart then?
Yes.
How do you use heat, or how do you get it apart?
No, you just use a little bit of muscle strength.
The muscle. Okay.
Yeah. It's easy enough. If you put a film on the pipe before you put the cap on, twist the cap on good, then take and run an extra bead around the cap between the pipe and the top of the seal, and let it cure overnight, and that is a very good seal. In fact, you do that at all the joints of the pipes.
Very good. Okay, so you can get it apart to for repair if you need to.
And the waterproof connector is good and tight. So.
And what I did was I used regular PVC glue for the very bottom, because if it's sitting in water for months at a time, that's absolutely impermeable. But all the other joints, I used RTV.
Bill, do you think you could slide it out the top if you had to work on it?
Yeah, it goes right out.
Okay.
Yeah. I mean,
Because it
I
looks,
didn't
it
use
looks,
this fancy 3D printed connector. I just wrapped it in bubble wrap and shoved it down in there with a yardstick, and it holds it pretty nicely.
the advantage of the 3D printed part though is it's going to hold it exactly vertical. And-
Right, right.
Yeah, that's kind of important.
Yeah, but you know, if you want to throw away that bottom section of pipe, the stuff is cheap. So even though you PVC'd it, just toss it out and get a new piece of pipe, and then you can work at the open end and in terms of you know, fastening correctly, and put the cap on again with PVC, and you're all set. I mean, the stuff is so cheap that you can throw it away.
Yeah, so I have a question for Dave Witten and Jules, who are building these bracketry to hold the board inside the pipe. We were talking with my CAD guy about eliminating the notch in the board. And you remember there's a notch on the left side of the board that was to clear the LCD connector on the Raspberry Pi.
Right.
So if you use the flex connector there, you would still be able to do it. Now, it turns out that if you do that, then you can't put the hole in the corner, because the hole is also over the connector. Now, personally, I think that first of all, if you're going to, it only affects the end that's on the Raspberry Pi. And second of all, I don't think anybody here is going to use that LCD display with the Raspberry Pi instead of just using it standalone with a console or with an HDMI connector. So I'm suggesting that we make the board basically square with holes in the four corners. And then if you really have to use the flex cable, what you could do is you could add another ribbon or another 40-pin connector and stack the board up a little higher to get a little vertical space to bring the thing out. So if you really wanted to use it, you could do it. So does that seem like that's an okay solution, or do you think we really need to keep the notch?
Hey, it's okay with me. I'm not sure about anybody else in the group.
I guess the question is, does anybody use that LCD connector on the Raspberry Pi?
No.
I don't know of anybody that does either, so that's why I'm asking.
Yeah, and they could, they can work out their own solution if they're determined to do it that way. Because there are alternatives, and I think better alternatives in most cases. The main reason to use that flex cable is if you're going to make a handheld sort of thing or something small and on a desktop or something, and really, it doesn't seem a likely way to go about this.
Yeah, we have a workaround also. If you want to put a spacer, you can still do it.
Yes.
Now the mount that Majid printed there only attaches at the sides of the boards, which shouldn't make any problem either for what you're talking about. I actually think it's kind of a better one than what I was doing, but it's not as easy to print or as quick to print. And so, it was probably a little cheaper to do the other kind like I did.
And the idea is if you can put the holes in the corners of the board that's symmetrical, then you can use the same mount on either end. And you'll have a hole for the cable on one end that doesn't have the cable, but that's okay. That should still work, right?
Yeah. Or two.
So Nathaniel, can you take that thing apart and show us that bracket again? That sleeve that he made?
Yeah, sure.
But while Nathaniel is doing that, I want to add another comment from someone who doesn't know what they're talking about and is doing this for the first time. So I set up the grape and that was all working, and then I got the magnetometer. Jules was very kind to send me some boards. But anyone who has a Raspberry Pi and has done this kind of thing before, it'd be very obvious. But So I bought the case that was on the list of the grape stuff. And so I get the magnetometer, and of course it's not going to fit in that case. And so then I had to order, I took it out of the case because I wanted it to work right away because I'm impatient and I'm generally a bad person. And so then I found out there were risers, and so I got the risers in there now. But I don't know how many people are running the magnetometer on the same Pi as the grape. And I realize this has nothing to do with the LCD cable. So this is sort of a point of order for general people who don't know what they're doing, like me,
And
that other people will run into.
I am running the magnetometer and as well as a GPS unit on the grape device.
And ultimately, we do want them all to be able to run on the same system.
Yes.
But you're talking about the Grape 1 at this point.
Yes.
Grape 1, yes.
Yeah, and
that's
they
true.
that was the designs of those were not really coordinated. It's great you got them to work.
Yeah,
Yes.
I mean, they do seem to be working. I can't complain. And I just wanted to bring up that this wasn't a point for you tech savvy people who would just figure this out immediately. For me, it was just like it won't fit, and so I figured out how to get it to work. And it does seem to be working.
So we need. I'd like to know how you got it to work, because this is going to be the production version, and we want it to also work with the Grape 2 as well as the Grape 1, and with the Raspberry Pi, obviously. So Bill, what order did you put the boards in when you stacked them up?
Well, let me see. Let me see if I can take the camera over here to it. I don't know how well.
While he's setting up, I also want to be a contrarian and say that I use an Odroid, and right now, just as a test, I'm using a NVIDIA Nano. So it works fine on there.
So you have no clearance problems with it?
Nope. The NVIDIA, it reverses and hangs off the side of the board.
Oh, it goes 180 degrees.
Yeah, the
out?
pin order is different because there's a big huge heat sink over the.
Oh, so they reversed it so you could still use hat
Yes.
boards. Nice.
But
Okay.
it worked fine in the Odroid too. So.
And yeah, because we're talking about bringing the cable off the opposite end, but parallel with the long side, which should work on the Odroid as well as the Raspberry Pi.
Right.
Okay. And I don't think the Odroid has that flex connector there, so we don't need to worry about that.
No, it doesn't.
There's always all kinds of options to use a 40-pin extender.
Yeah.
Yeah.
All right,
Like
so
the-
I'm showing my screen. You can see the bottom is the grape as it came from John, and then I've got one riser that comes up out of the grape, and plugged into that is the GPS unit I use for getting location and timing information, and on top of that is a magnetometer board.
Did you need a spacer to do that?
Well, I don't know. No, not really.
It's not ideal to have a PC board over the GPS antenna.
Well, the antenna is outside. See that
Oh.
cable there?
Okay, well, you've got an antenna on there, but you're not using it, I take it.
Yeah, usually that disables when you put on a external
That makes
antenna.
more sense.
Yeah, I wouldn't be able to get I wouldn't be able to pick up. I'm in the basement here. I have to have an external antenna to be able to get a GPS signal. So
I just saw the antenna.
So the base unit that you call the grape is actually a Raspberry Pi and the grape and the power supply, right?
yeah, well, there's a Raspberry Pi, and this is, I guess, what you would call the grape. It's the Leo Bodnar and the little board that was built by John.
Right, but that's all in a stack.
And then there's that goes to a USB extender so that I have everything you know, you've got to plug in your mouse and keyboard and your external hard drive, and there's no clearance to do that unless you use an external USB extender box to go into.
Okay, but stop right there. That stack that you're showing right now. No, up to the upper left there. That stack. There's a stack of boards underneath your GPS, right? What is that?
That is a stack. That's kind of deceptive. What that is. That's just the way the box, the chassis, or rather the case that came from Case Western Reserve is. It looks like a stack, but it's just a case.
And what's in it? Just the Raspberry Pi?
The Raspberry Pi, and I put an extender in to bring the GPIO out of the case.
Okay, so then you have the Raspberry Pi inside the case, an extender that extends it outside the case, and on top of that you put the grape board, right?
Well, no, the grape board is down here. It's separate.
Oh, it's separate. Okay, so on top of that you put the GPS, and then on top of that you put the magnetometer.
Yeah, the magnetometer base. Yes, everything works like a champ. Worked first time, and no problems at all.
Is that extended? Go ahead. I'm sorry, Scott.
Oh, I was going to say that. But when we get a Grape 2, isn't the Grape 2 going to go between the Raspberry Pi and the GPS unit?
If I'm not familiar with the Grape 2 design, if it's going to plug into the GPIO header of the Raspberry Pi, I guess it would go in between, I suppose.
Yeah, that's what I think John has the intent for it to do. So, but it would still work in the same way. You just have an extra board in your stack.
Right. You can stack them up as high as you want, I guess.
Okay. Hey, Bill, it looks like that extender. Is that a homebrew extender board with a vector board?
Extender board.
That is the one below the Pi. The board below the Pi looks like vector board and perf board.
Yes.
Oh well, it's just the lighting isn't very good here. It's just an extender. What would you call it? It's just an extender unit that I bought from Dikikey or Mouser or somewhere.
Okay, it looked like it was made of perf board. You know, the vector perf board.
No, it's probably because I don't have very good lighting. It's very hard to see this. And I've got some other things are bolted down to the desk here. I can't move it back. But no, it's just nothing. Between the Raspberry Pi and the GPS is just one of those 40-pin extenders.
Oh, okay.
A long pin header, you mean?
Yeah.
I guess that's what you would call it. Yeah.
So what is the thing that looks like perf board? Is that the board that the GPS mounts on?
Yeah, the perf board, the first this thing here is I guess it looks like perf board. That's just a GPS board. It's an Adafruit GPS, I don't know, $40 or something, and it gives you GPS.
Okay, and that has the holes that look like perf board there on the right hand side.
Oh yeah, that's just part of it. It's the way it comes from Adafruit.
Okay, so I think that's what
that's
a prototyping section on
you can add more stuff to it if you wish, but
it's a prototyping section. Yeah. All right, got it.
So I think the idea is that the Grape 2 is going to go right in that stack. That's the way John is designing it. And then if you want to substitute the Tangerine for the Raspberry Pi, it should also work in that stack.
You would think, yeah, it should.
I mean, we designed it that way so that the pins that he uses are all pins that I drive. So we
to
talk to it.
So I'm not clear. What is the Grape 2 doing? Does it have its own
it's a
GPSDO and
it's a
audio card and such?
It's multi-channel. It's multi-channel. That's the major purpose of the Grape 2.
But why is it going in with the Raspberry Pi stack?
Well,
just to get it out of the way.
Yeah, I mean it's using the Raspberry Pi as the compute engine. I mean the Grape itself is
I know, but the Grape 1 goes through audio card and the Leo Bodnar, and that's all it's connected to.
The Grape 2 goes to an I2S channel that talks to, all 4 channels talk back to the Raspberry Pi, and it gets its data that way.
Oh, so it's got an onboard ADC?
Yes, 4 of them.
Ah, that's the answer.
Yeah,
Okay,
so it
okay,
doesn't,
'cause
It doesn't go through the audio card the way.
Yeah, it
the-
doesn't use the audio channels. Right. That's the difference.
Okay, because my magnetometer is on top of the Pi, and the Grape One is off. It was supposed to be a large metal junction box that ends up being a cheap toolbox from Harbor Freight that it's living in.
so the Grape 2 will.
I guess I can't post a photo, but so they're all laid out in this little metal box with various grounds.
So the idea is that the Grape 2 then will go right in your stack of Raspberry Pi boards instead of being off to the side. I think that's the intent John had.
Yeah, it just plugs right in. It gets its power that way. It's physically nice.
So a more apropos question would be, why would you plug that onto a Tangerine? Because the Tangerine already has simultaneous receive of the whole band. So why would you really, I mean, you can do the same functions directly with the Tangerine that you can do with the Grape 2. And I mean, we just made it that way because we could. It's not really going to be necessary.
Yeah, I don't think anybody's suggesting that we plug a Grape 2 and a Tangerine onto the same. I mean, you could, I mean, but.
We could, so then we should allow it, right?
Well, I think you're probably pushing the capabilities of the Raspberry Pi at that point to be able to handle data from both devices, but yeah, whatever.
Well, at least
probably not, because
you're not going to burn anything out.
we give it a fire hose from an RTL SDR. It handles that fine.
Before we leave the discussion on boards and stuff, regarding Bill's idea for the way he sealed his pipe, the lower end of the pipe with a cap, the more I think about that, I'm in favor of that just because the PVC is so cheap. So when you seal the bottom with the cap, use PVC cement after everything is set up and or lined correctly. And then if you have to pull it out of the ground again and do a new replacement, just discard that piece of pipe and put a new one on.
You just carefully cut the bottom 4 inches of the pipe off and slide the magnetometer out and make it just a little shorter.
You could do that. You could also pull the assembly up. But you
out the other end.
Yeah.
Yeah.
As I say, I've had no problem at all with in damp, not necessarily standing water, but almost groundwater with the current setups that I have for over a year and a half.
So do you put any desiccant or anything in the bottom?
The only thing I did in both of mine was I put a couple of packs of silica gel to handle any moisture that might have originated from any humid air that might have gotten trapped when I closed the pipe up. That's all I did.
Sounds good. Yeah.
That's a good idea. I didn't think to do that, but it's definitely a good idea.
So I wanted to give feedback on, since I am the one that destroyed one with water, I want to give some feedback that it did not come in the bottom of my unit. It overflowed the top.
He's got a very wet backyard.
Yeah, there was standing water around the hole.
Oh dear.
It was like burying your thing in a mud puddle.
So did it come in the T or in the cap?
Not the T. It came in. I was using 4-inch pipe too at that time, and I'm not using that anymore. But and actually, right now mine's above ground on the stick to keep it from away from the water.
I think what you're saying is we need to properly account for climate change.
Yes. So
for rain, I mean, we've
just come
for the past 2 months here in Alabama. We've been getting 3 to 4 inches of rain per week.
Yes,
right. That's just moved to New Hampshire now. We're getting flooding now after coming out of drought.
the end of June, we got 6.8 inches of rain in one day.
Wow, that's our
Wow.
annual rainfall.
Not quite, but
Yeah,
until
not quite the
last
same-
week.
Not quite the same level, but we've gotten 6 to 12 inches of rain the month of July, which is very unusual for us.
How much did Flagstaff get the other day? I don't know.
Flagstaff gets snow in July.
Would anybody have any interest in seeing this monitoring software? I have it running with dummy data.
share your
Yeah,
screen.
definitely.
Yeah, I'd like to.
Absolutely.
Okay, let me see. Let me find, see if it'll work. Yeah, can you see that?
Yes.
Yes.
Okay, well, that is actually running, should be live.
Yes, I see it move.
And it, you can, see, well, you can pan in and
Nice.
reset. I haven't really got it full pan. This at the bottom is temperature. It's actually X, Y, Z, and the totalized thing. And this is all running from a unit that's sitting on the desk across the room, and that bears absolutely no relationship to the real magnetic fields around here. But
Well, you're reading it off of a real board, right? It's just that it's inside.
right. And this also at the same time is able to push logs to the archive up on the, it saves, and but it also, this is actually a WebSockets interface that's served up by the device. It just serves up the page, and then it communicates by WebSockets. So this data gets plotted, but it can be anywhere. The way it's set up right now, anywhere on my local net, on the subnet that I use behind my firewall. You could push it out beyond, but I would suggest that people don't. And it's a little complicated to set up so far, and it's by no means done. I'm working on also writing the metadata through this interface onto the Raspberry Pi. Now, I'm sitting at a desktop, but it's a Raspberry Pi that's actually doing the data collection, and so some more control that way. We're not, and I was kind of thinking of doing what I think something along the lines of what Bill has been doing with the configuration or this setup, nulling things and all too. This could be pushed to a cell phone or something that could use the local Wi-Fi, but that's not a real high priority. Anyway, this is just to show it can be done. This is not meant to be part of any final strategy of the overall project. This is just so for the time being, a person can actually see that their magnetometer is really doing something. These are kind of nice little time series plots that I've got. I can actually refresh the whole thing, and you should be able to see it, pulling in. I haven't figured out exactly the presentation here, but
you have control over the time period that it displays, or it's from the beginning?
Yes, I do. Well, this itself doesn't record anything. So it's really from the moment you reset it. But there are a lot of questions I've had. I've been thinking about, what this doesn't read the logs or log data or anything. And I'm concerned how much I want to pump into this interface. I don't know, as usual with web stuff, you don't always know what's going on inside the black boxes.
Yeah.
I've been trying to watch memory usage in some of Google's tools.
Yeah,
And
I'm
it
just
seems to be
noticing the
clean.
way you have it set up, the time scale is constantly changing.
Yes, it is.
It'd be
And
nice if you could just tell it, you know, display
can
the
do-
last hour, display the last day or something. And when you restart it, it would just start from the right-hand edge and fill in.
I plan to do that.
Okay.
I was, the question is, should it automatically restart? If someone leaves it running, should it automatically restart at 00 UTC, or should it try to keep? I was thinking maybe show the last hour or two and but give it the ability to pan back and forth through, say, 12 hours or something like that.
Well, ultimately, we need to be able to keep track of days too, because
Yeah.
you know,
Now, but-
geomagnetic storm's going to be more than just an hour.
yeah, but those all that data is being written to the log files for post-processing purposes. This is not intended to do that kind of thing. It's mostly to show what's going on right now and is my thing working. And in fact, it's supposed to change color if you lose your link. But I may have clobbered that somehow. It's the background's supposed to turn pink or something. It seems pretty reliable. I've run it for a day and a half at max, but there are lots of things to tweak about it right now.
Yeah.
I just wanted to show that just to.
I just wouldn't have it auto scaling with time scale.
Yeah, it's taken me, the terminology of these it's kind of like financial terminology or something on this particular these time series graphs, and so I've kind of had to figure out what they mean by what they're saying in terms that I know.
That's something about where the code came from.
Yeah, these are, you know, this is should be a 10, it should be smooth with a 10 sample moving average. They call it roll something, but it took me a little bit to figure out what they were talking about. And there are other things also, yeah, and this is the default behavior. It is showing UTC is the time scale, but it's UTC as understood by my desktop here, not as understood by the magnetometer. I'm not using that to plot yet the x-axis, but it's just showing. And the thing is, this is decoupled from the Raspberry Pi to a fair extent. This is not a lot of heavy duty stuff added to what's going on the Raspberry Pi. It's a presentation of really just the data points that come off the Raspberry Pi. And I just wanted to show that that was possible.
Well, and Dave, this is more of like a, you know, if you want to see what's happening immediately for testing or alignment or other purposes, because I mean, as you point out, the log file is being created. And so you can.
Yeah, but the whole point is to be able to see it. Log file doesn't do me any good. It does the researcher some good, but it doesn't do me any good to see what's actually going on.
Yeah, well, different people are going to have different things, and that's really part of why I wanted to show it to folks at this point, is see what y'all.
Yeah, but how hard is it to set it to a fixed time base?
A fixed
time scale.
Oh,
instead of having the scale constantly changing, which is just
probably
driving my eye nuts.
Well, probably not hard at all.
Okay.
But
yeah, just even having it as a running
well,
strip chart, but not changing the time scale. Have a constant time scale, and you know what I'm used to with strip charts is that you can tell it what time scale you want, and then it just streams across it and gives you that rate.
Yeah, I believe it can do that. It's just that it was not obvious from the very beginning
Right.
what the settings were to make it behave that way. But it had so many other, as I worked with it, it had so many other useful features. Unfortunately, the website that it's got good documentation, but somebody hasn't been keeping up the website very much. So a lot of the links to examples, you have to go out and run them from the GitHub code and things. They don't work from the website, and it's just the usual bit rot that goes on in the but yeah, well, this is just where I've gotten to it with in about a week and a half of messing around. And to me, the really important thing is that it's using an intermediary. It's actually currently it's using an intermediary WebSocket server. There's a little web server also. Supposedly, the web server I was using could be the WebSocket server also, but I couldn't find any documentation how to do that either, except a little bit in the Lua, which didn't seem to be the way I wanted to do it. And so I did this. This is using named pipes from the otherwise, I just modified. I've got a version of the RunMag program that opens a named pipe and it writes pretty much the same data to the named pipe, to their FIFOs really, that it writes to the logs, and it just ingests them and plots them. And in the behind the scenes mechanics were more my concern. But yes, I need to get it so that it doesn't offend the eye. And there are no small number of things about this that offend my eye at this point. But it's there, and also trying to put in something to allow. This is just trying to work on a widget to try and rationally put into here. Store in the metadata what the orientation of the magnetometer module is within the in reality, because we're not using it as PNI really intended. We've got it partially rotated, and it's possible somebody might want to do it some other way. And so we need to, swap X and Y and make some of the values negative where they're positive and so forth. So I'm working on that, but that's where this is. I don't know that this is anything like anything anyone wants to use in the PSWS project, but it's just something for the here and now. But it's almost here and now. Let's say, give me a little while to finish it, and then.
Well, Dave, I really like this. I mean, it looks like something that would be cool to show on a local host as a strip chart.
You can do it on the local host, but to me the really nice thing is that you can run it on the local host, but if you don't want to put a display on the local host, you just want it on some other machine somewhere quite else, it works just as well remotely.
Yeah.
And that was my goal in writing it this way. And it's really not very different code than what you're already playing with. So
yeah, I really like it. I mean, because the local host uses a web interface. So when you have your local host running, you can control your local host from another computer somewhere else.
Oh, okay.
And you can do that with this too.
Sure. Oh, okay. I see what you mean. The interface you have on the local host at this point.
It is web-based, yeah.
I see. Okay. Well, this is a very lightweight way to do it, at least in terms of, the amount of any load that's added to the local host.
Yeah.
So this will end up in a GitHub for any and all who have interest in it.
This
right.
particular code I presume it's auto scaling the vertical, so that if you get some wide excursions,
Yes.
they will bring down the scale rather than clip.
Yes, I set it to that to begin with. It yes, it auto scales in the vertical. Initially it wasn't doing that, and I was getting funny, really
How hard
funny.
is it to tweak the scale parameters in this code?
Well, it's just in the JavaScript to it seems to be incredibly flexible.
Right.
And the only trouble is it seems to be a fairly tight club of people who've used it. It actually can be used directly from R. It has an R interface, and from Python, I believe, more directly, rather than even having to, you have to do something like WX Python or something that encapsulates a web browser. But
So, again, what's the package that you're using?
The graph is called digraph. Here's I don't know if you can see.
Yes.
Do you see my
Yes.
Dan VK digraphs? I happen to have it open, and so it's interesting. It's just, it's been kind of lying fallow for 4 or 5 years, but I think it's actively used by somebody for something. But it's really more for financial. Actually, some of their things are temperature, but and at first I thought it would only do two traces, but that turns out not to be true at all. There's some much more complex examples that I don't entirely understand. But when you start something like this, or when I start something like this, it always seems to be a matter of going out there and just looking around and seeing what you find, and trying to eliminate the ones that are going to give you the worst headaches, and hope you get lucky with something that will do most of what you need. And this one seems to be, with the only caveat that the terminology just strikes me as peculiar. It's at least it's not immediately intuitive to me. It seems to do an awful lot of what I wanted. And it's dedicated to time series type stuff. So, and that's pretty inherent. There's not, there's not a lot of, there's some little bar charts, but sort of things, but there's not pie charts and other stuff particularly. It's not business graphics in general. So this has so far been useful, and I hope somebody sees some use in it. But it'll take me a little longer to get it in. The main problem right now is that you have to have a web server on there, which may not be a problem. Sounds like Bill's already doing that on the local host. Any web server would do. You need something that can handle WebSockets, which, if you're using Flask or something, surely there's a plugin to do WebSockets there. But I'm actually using a what did I do? Something called G WebSockets, which is a C program that seemed to be tested. It had been they had run it through a lot of fuzzing and stuff like that, and I thought that was good. I
So
wasn't sure.
even if you're displaying it locally, you have to go through the web. You have to be connected to the web.
The way this is, well, you could no, I think I haven't tried it. No, you don't have to be connected. You have to be connected to the local. Well, you'd be running just local socket back. I'm pretty sure you can essentially open a local host socket. The data is just coming through pipes to this G WebSocket, and then the G WebSocket WebSockets has some headers and things. It's one of those enhanced protocols for, it's kind of an extension to sockets to make it work well in this kind of an environment. And this intermediate piece I'm using right now just converts from the piped JSON objects that are coming out of RunMag and pushes them into this. And so any way that you can get that to happen, but I believe this would work just fine locally as far as I know. I'll have to try it, but I haven't hooked it up to my outdoor magnetometer, but it looks like the guy with the lawnmower may have caused me some grief on that account. So anyway, that's what I've been playing with.
In Greenland, it wasn't lawnmowers, it was snowmobiles.
Yeah, I doubt there's anywhere on Earth you can go that doesn't have something that
something's going to chop it.
But anyway, that's just to show that I'm not sitting around doing nothing.
I think that all looks very encouraging, Dave. I like it a lot.
Now, I asked a question earlier. I don't think there was an answer. Is there a way to get actual RF data into the Max 10 evaluation board?
Not right now. We're talking about building an adapter for our RF module. Okay. Although I do have some spare boards floating around if I can find them. I think Dave's left, but Dave has one of them. It's an AD1, which plugs onto a HSMC connector, which that board has.
Right.
And it converts it to an MEC connector, which allows you to run an HF1 or HF2 receiver board that we sold priorly. So yeah, there is a way to get some RF in. The HF2 board is probably the best bet since it uses 122.88 megahertz oscillator.
Right.
But they're a product that we sell, but they're expensive. So I may be able to pry a few loose for us to use.
Right.
And,
okay.
Get that way. Otherwise, we'll have to build an adapter. The adapter is pretty easy. It's just connectors and traces, and maybe some bypass caps on the power lines. But
right.
Nothing.
Well, the other idea, I'm wondering, it has 2 Ethernet ports on the eval board. Any way to connect either a USRP or Red Pitaya to send it data?
Well, I mean, you're kind of duplicating the function that you want the Tangerine to do, right?
Right.
Once you've got Ethernet data, the Ethernet data is supposed to be the output of us.
Yeah, well, yeah, except the USRP, for instance, you bring it in, you work with it, and then you send it back out again.
Yeah.
I mean, USRP has some processing on board, but I know UHA doesn't do very much on the USRP itself.
And USRP is pretty expensive too.
Well, I'm just saying, I've got a USRP, I've got a Red Pitaya. That's why I bring it up, because I know they interface through Ethernet.
But for the purpose of building code, I mean, you really need to get raw data in a clock. I mean, that's,
right.
And then you could pretty much do it. It won't be exactly the same because the PHY is different. on that
Yeah.
board, what we use. So it
But
will be.
if you can get it through the HSMC connector, is it going to be close to look close enough to be useful development?
I think so, because it's going to be basically the same kind of connection that we have already to our real board when we get it.
Right.
Maybe different pins, but the same type.
Yeah,
of,
but the same data format is the idea.
right. And I did check. I took a look at that board, and I believe that the banks that we can use are connected to 2.5 volts already, which would be required, and because a lot of those boards are not strappable. And I don't
Right.
think that one is strappable. So, but luck would have it, it's strapped to 2.5. It's hardwired to 2.5, which is exactly what we need. So,
right,
it's doable with a minimal amount of effort. Of course, I gotta find a way to pay my CAD guy to lay the board out because it's beyond my meager CAD capabilities. But we'll figure something out because I think it needs to be done. We can't sit around and wait till May. So, and now that we seem to have a supply of these boards, it makes it even more worthwhile to do.
Hey, real quick, Dave, what are you using as the server for hosting the WebSockets?
Me?
Yes.
Oh, on well, the one I'm using there. Are you talking about the one I was just using in that demonstration?
Yes.
It is a Civet Web. It's a CIVET web, and it's a scalable web server that can be built. It's all in C, and it can be built for anything from larger,
Yeah.
some of the.
Which piece of equipment is it running on?
It's actually running on the Raspberry Pi.
Okay.
Okay. There are other choices.
Okay. So it's CIVET web.
Yeah.
Okay. Thank you.
Yeah.
I
may still rewrite stuff in Python, but
yeah,
not. This is working.
Okay. I just ordered the development board from Dikikey. So their quantity is dwindling fast.
Sir, are we not allowed to sign off until they're all sold out? Is this like a telethon tonight?
Order before midnight tonight, so you don't forget.
I'll buy one if I have to.
So John, to Tom, that means we don't need George's board?
If it ships.
Scotty, I've got a red Pitaya here. Would Kung benefit from playing with that at all? Since it can run?
Not sure that's true, no. He could play with it certainly and help him get up, a feel for SDR, but for us, I'm not sure it will do much.
Yeah, but isn't it does emulate the HPSDR, doesn't it?
Yes, it does.
And that code, the FPGA code is open source, right?
That's true, yes, but
So
it uses a Zinc, I think.
I think you're right.
So, but that's not necessarily bad. It's Verilog's Verilog, right?
Right. So it may give him another board he can look at, and this is one that will actually collect RF data. And I do have some extra HF receive antennas in the garage. I could give him, and he could play with it.
I'm thinking what might be better is the Kiwi uses a Zinc too, I think. There's one that uses an Altera processor. The Lime, I think, does. And Altera FPGA, and that code's open source also.
I don't have any Limes here. I've got Kiwis. I have Kiwis and Pitayas.
I have another obscure version that is Altera, and that's a TI development system.
An SDR?
Yeah, it's a high-speed A to Ds.
We should also talk to Kung, Scotty, because I told Kung that you'd meet him tomorrow afternoon, but you're saying that you'd like to meet him after like 4:30 tomorrow, right?
Well, we can do whatever you want. I just, that would be my preference, but
Yeah.
you know, whatever he needs to do.
I don't, Kung, would you be available tomorrow after the Radio Blaster Physics Camp to meet with Scotty?
Oh yeah, absolutely.
Okay. Yeah, because Scotty wanted to he was really excited about actually doing the Radio Blaster Physics Camp. So
If I'm just going to sit in the corner, then we can go meet somewhere. But if I get to participate, you know, radio camp, oh boy.
I agree.
Like I said, when I lived in New York, they always had a radio camp in Pennsylvania, the Poconos, and I never got to go.
And here you
So
are.
this is my substitute radio camp. What, 50
in the
years later?
Poconos.
In the Poconos.
and you hey Scotty, you also need to tell Bill Engelke. Is Bill still on here?
No, he had to go.
Because you got to see the famous street corner today.
Oh yes, yes. The 30,000 pounds of banana street corner. Well, I'll get them next week. We got to keep the 15 tons of bananas story going.
Yeah, 30,000 tons.
30,000 pounds.
30,000 pounds. Oh yeah, 30,000.
That's 15 tons, right?
Yes, 15 tons. That's right.
And I tell everyone else here, I gave a presentation at the Thunderbird Amateur Radio Club on TangerineSDR on last Thursday.
Mm-hmm.
And I actually had the slide of the banana truck overturned on Music Street with an explanation of what happened. And I explained to them why there was a banana truck upside down picture in my presentation. So it's a long, convoluted story.
The
But I have a
generational
slide.
thing.
Well, you know, it's like, what do they call that? How many degrees of
Degrees of separation?
Degrees of separation between you and Kevin Bacon, right?
Mm-hmm.
And the theory is that everybody has no more than about 3, maybe 4. Well, there were a lot of degrees of separation, shall we say, between the SDR presentation and the banana truck, but not so many I couldn't put them on a slide. So they
That's a
could see
very
that.
appealing theory, Scott.
Well, it started out with them asking me to present, and it worked its all the way back to Nathaniel, who drives down that same road every day to go to work. The same road that the crash happened on in 1965.
Can I break in here?
Doesn't.
Can I break in here and ask Dave what software he's running on this?
On the RTL SDR?
Yeah. I'm trying to get it running with SDR sharp, and I've got it going, but all I can see is a commercial FM band, and I want to see the satellite band, and I want to see HF. And is there something other than SDR sharp? And is there anything on Linux that you can run?
Well, yeah. Well, we're actually running it through GNU Radio.
You can use Cubic SDR. Yeah,
and the thing is, if you're asking HF, it does 24 megahertz and above. There's
this one's got HF on it.
Yeah.
Oh, yeah, that's kind of a misnomer. What it is it's direct sampling. Goes straight into the A to D.
Yeah.
You have to kind of build your own front end for that, but yeah, it does do that.
Okay.
And you have you have to adjust something or jump or something in the
No,
RTL,
these ones, the newest one, it is software switchable.
Okay.
You may want to look at GQRX also.
Yeah, that's the other one.
Yeah, and the older ones, you actually had to open it up and jump onto a couple of the pins. But these, they've designed a software switch, and some of the SDR packages. I know I've used it with HD SDR. We use it with the new radio, but you have to do your programming with that.
Well, GQRX is actually built with GNU radio. It's just a GUI.
Oh, there you go. Yeah. Which one is that?
Golf Quebec Romeo X-Ray, GQRX, runs on Linux.
Yeah. Oh,
built
excellent.
on top of GNU radio.
Oh, great. That helps.
I think I'm going to sign off for tonight because
before we go, could I just talk about my progress quick?
Sure.
Okay, I will share my screen. And
oh, by the way, Jonathan, I had a thing out there to see if I could get some of the ADCs, the 6140s.
Yeah.
I got a note from TI that it was back in stock. And when I went and looked, they weren't there. And I was told by TI, oh, well, we sent it out about 15 minutes after they go into stock, and they were gone before that.
Wow. It's a really good thing that Scotty purchased those.
I have not determined whether we gotten any yet, but I'll have to check the back order and see what their status is.
They're still showing quite a ways out. Other
But
than
if they put some
having
in
them
stock,
randomly show up.
If they put some in stock, we might have actually got some of the back orders filled. Because we
now, were
ordered
you
it
getting
back
them from TI or from Dikikey or what?
from Mauser, I think.
Mauser, okay.
And they were supposed to have a delivery in August, so it's a little early.
Well, yeah, it's a good thing that you got those that you ordered. But so this is what I was working on this past week. This is the PVC pipe antenna. As a temporary mount, I used one of those large umbrella mounts. I was testing it this weekend, and I was able to hear spherics and everything worked really, really well. I was very surprised, but also very thrilled. So this is an 1.5 inch PVC pipe. You could see on the top here, there's a cap. So I was thinking about this. I'm not going to put PVC cement on this cap, because if I ever have to get the antenna core out, I would have to cut the PVC. And I believe with it banged down there enough, I really don't think all that much moisture is going to get in.
Yeah, you could use some RTV there and then be able to twist it off.
Yeah, I was also thinking about that too.
Just run a bead of RTV around it with it vertically out. There's no way that moisture is going to run back and wick underneath.
Yeah, I was thinking that. Yeah, that's a good idea. Yeah, so I'll be doing that. So I'll be using that. The wires come out the bottom. This yellow here, this is a yellow nylon string, and you could pull out the smaller foam core. This gray wire here, this is the earth ground. This is a Cat 5 that carries the power and the signal. And what's going to go on here is a bunch of adapters with a threaded fitting that I could unscrew the fitting, and I could pull out the foam core. And I could also push it back in. So this is going to have PVC cement on here. So I'm going to put the PVC cement on here and some primer with that adapter, because the moisture is going to fall onto this, and I want to make sure that this is sealed. Although it's not really that big of a deal. I could probably use silicone too, but I didn't want any moisture getting in under here.
I'll mention one thing that we've done. We actually use rubber stoppers with holes in them and make a slice so that we can put the cable into the hole. And then the stopper goes into, we use an end cap with a appropriately sized hole. And then the stopper fits into that and seals.
All right, yeah. I actually use something similar. It's not pictured here, but that threaded cap, what I did was I installed a cable gland. And the plan was to feed the nylon cord and well, actually that could be put inside, but feed the cables through the cable gland. Paul, through his experimentation, he recommended leaving the cable gland open so moisture could evaporate out if it does get in. And since it's on the bottom, moisture shouldn't really get in all that well.
Yeah, the term for antennas that we use is you need to have a weep hole.
Right.
So that moisture can run out the bottom.
Yep. That's exactly what Paul mentioned. Yeah. So I got a cable gland, the same as the one that I used on the Raspberry Pi box. This is just one of those stakes that you use to stake down weed fabric. I use them in my garden, so I just grabbed one, and it was a good enough earth ground. This is my test box. You can see, power and audio. There's the volume control here, the toggle switch, and it's currently routing the audio signal through this RCA jack. And that was plugged into my phone, and I was able to get the live spectrogram. This is another view of the top cap. Let's see. So this is the foam core. So there are two foam cores. One is the long antenna core, and this is a smaller core, because with that long antenna core and all the friction with that copper tape, trying to push it in, this foam was crushing, so it didn't really work all that well. So I thought, well, I'll just make a separate core so I could pull this out, because like if anything happens to this, I'm gonna have to get to it to repair it. So I made this a little short foam core. There's actually double-sided tape on the bottom of this board, and it's held in place really nicely. This is a close-up of the connector, 2 for audio, 2 for power, and 1 for earth ground. There's actually 2 more for a calibration transformer, but I never utilized that yet. This is the button that I was talking about. It was just a cap from a gallon jug. I put the string through and used double-sided tape to attach it, and it works really well. Yeah, this is a better view of it. Here's a better view of the cap. This was originally on the antenna core, but I took it off. These are the spectrograms that I recorded on my phone. You can see down here, this is 60 hertz power. You can see how strong that is, and all of these here, these are all the harmonics of 60 hertz power. It overloads the receiver in a lot of cases, but it didn't overload the mic input of my cell phone. But you could clearly see the spherics here, which is a very, very, very good sign. I messed around with the settings to try to get the contrast a little bit better, but this is the best that I can get. If I use something like SOX, I could probably generate a better spectrogram with more contrast. But I believe the reason why I wasn't able to get the contrast was because of the strong 60 hertz and the harmonics, kind of overloading it. This is with whoops. So this is on battery power, and this one is on powered by the DC adapter. There's just a little bit of added noise with the DC adapter plugged in, but it's not that much. But you can still see the strong 60 hertz. So once this is installed in a radio quiet location, this 60 hertz isn't going to be that bad, and it should be very easy to filter out. When the time comes, it's going to be installed at using antenna mast clamps on an aluminum mast, so as not to interfere with the magnetometer. Since I plan on driving the mast, it's going to be a 6-foot mast. I'm going to drive it in probably around 2 feet, so I don't think that I should have to guy the mast. If we can, you could get those guy rings that attach to the mast, and you could use cable or rope to guy it, but that might not be necessary, and it would make it difficult when you're there with the lawnmower. But other than that, I'm actually really excited with the progress and the performance. So the next step, what I have left to do, is I have to add some gas discharge arresters and leader resistors to the circuit board in the Raspberry Pi box to add some protection, and this will be complete and ready to install. That's all I have. If there's any questions.
Yeah, Jonathan, what's the app that you're using on your phone?
It is, well, this is an iPhone.
That's too bad.
Yeah. well, I actually like iPhone.
I'm just
yeah.
I'm wondering what spectrum analyzer application you're using.
It's called Spectrum View. I don't know if it's available for Android too. I think it is.
You spelled V-I-E-W or V-U?
V-I-E-W, yeah.
Okay.
Yeah. And actually, to get it to work on my phone, and you probably have to do this for Android phones too, is the only audio input is the microphone input. But on the iPhone, the microphone input has a 2.7 DC, a 2.7 volt DC bias to drive the microphone of the headphones. If you do that, just make sure to install a DC blocking capacitor so as not to short out that bias or.
Yeah, even if you didn't, it's probably not a big deal because it's a high impedance.
Yeah.
But yeah, you prefer to DC block it.
Yeah, and I actually use this with an older iPhone 4S, and this is an iPhone 6S Plus. So before, when I originally did this, I was using my portable portable VLF receiver, and I was looking and I was also using that same app as well. So I'm guessing the spectrogram would probably have more contrast when I get to install it at Nathaniel's house, because there's not going to be 60 hertz isn't going to be that strong. Where I was, 60 hertz was very, very strong. If you turn the volume up, it would actually hurt your ears. So, yeah. Oh, and another interesting thing, the LCD screen of the phone. Apparently, there's a DC to DC converter. At least on my older phone, it generates some emission, and you could hear a tone if you have the phone close to the antenna. So if you're doing this, make sure to do it far away.
I think that sounds really good, Jonathan. I think I'm going to need to call it a night. It's really kind of past my bedtime right now, but I think this looks really good.
Yep, I think I will too. I got to get up really early tomorrow, since I'm in the wrong time zone.
Don't you have to get up at like 3 a.m.?
Yeah.
Sounds
good job,
good,
Jonathan.
Pardon?
Same here, guys. 73. Nice job, Jonathan.
Oh, thank you. Thank you, guys.
73 joules. All right, Jonathan and everyone.
All right. Have a good night, guys. 7-3.
7-3.
Hey, Dan, do I need to be there tomorrow?
You don't have to, no. It would be nice if you were, though.
Okay. I'll see what I can do. It's noon and 1 our time, right? I mean, Eastern time.
Yeah. Steve is going to do like a demo. So it's going to basically be a camera shot of the spectrum analyzer, I guess.
Okay. Well, I'll see what I can do. Noon will be lunchtime here, and then 1 they'll be starting up again. So
yeah,
we'll see if I can sneak away for a few minutes.
Okay. Yeah, if you could be there, it would be nice, but it's not essential, I guess.
Okay. I'll see what I can do.
Okay. Talk to
Thanks.
you later.
Okay, bye.
Bye.